evening's talk, and without further ado, I'd like to hand you over to the first of our speakers for tonight, Tom Brennan.
Okay, thanks, Rowan. I hope everyone can hear me there. Thanks for the introduction. I'll give you an overview to the background to the development of the scheme. Ursula, Higgins and Shane Tobin then from Atkins will, I suppose, deal with aspects of the design, the detailed design of the scheme, and to followed then by Brían Flynn, who will go into aspects of the construction of the scheme. So I suppose I'll just deal with like what is the Western Distributor Road, why is it being built at this particular point in time, and what's it going to do for Sligo. I suppose the Western Distributor Road is a strategic non-national road, and it's been, as Rowan said earlier, it's been included in Sligo City development plans since the 1960s. This map here gives you a layout of Sligo City. Basically, the N4 Sligo Inner Reef Road runs adjacent to the city centre. And you have the Strandhill Road, the R292 regional road linking Sligo and Strandhill. And the Western Distributor Road then fills out the southwest quadrant of Sligo City from the Caltra interchange linking round to the Strandhill Road. And I suppose a major objective of the Western Distributor Road will be to allow Sligo to fulfil its potential as a regional growth centre and to facilitate the attraction of new business to Sligo, including foreign direct investment and all the additional employment and economic activity and prosperity that might bring. In particular, it will allow for the development of these lands to the southwest of the city, and the IDA have a considerable land bank adjacent to the new road, and this will allow the IDA to develop their new Oakfield Business Park, and will also improve activity or access to the existing Finniskillen Business Park. The road has been in development for many years now, and I suppose development works first started on it in the 2000s, and it's finally finished now in recent months. So I suppose the background to it is, and what it does for the city, Sligo traffic and transportation studies since the 1970s, I suppose, dealt with how the city would develop from a transportation point of view. And if you go back 20 or 30 years, maybe 30 years ago, Sligo City basically had two bridges over the Garavogue River. Sligo is like an hourglass. The River Garavogue goes through the centre of it, and there's only a very short length of a crossing point. And the city centre, in days gone by, say 30 years ago, one of the bridges was the 17th century Markovich Bridge, and the other was the 19th century built Hyde Bridge. So the transportation plans, I suppose, suggested the construction of the N4 Sligo Inner Reef Road, which would bypass the city centre and allow the city centre to be traffic calmed and to enable, I suppose, public realm projects, which we're realising at the moment. On the eastern side of the city, the Eastern Garavogue Bridge was proposed to link the northeast of the city with the southeast, and we expect this project to be delivered in the next few years. It's at an advanced stage of development. And on the west, then we had the Sligo Western Distributor Road linking the N4, the Caltra interchange, to the Strandhill Road, and this will allow the southwest part of the city to develop, including business-owned lands at Oakfield. So it's part of an ongoing process. As I said, Sligo City development plans for many years have included the Western Distributor Road, and the more recent plans in the 2000s and 2010s have had a specific objective of the T1.2 road. And we can see from this slide here, suppose all the land that's zoned in the vicinity of that roadway, and the land that would be required, or sorry, the road is required to facilitate the development of these lands. And in particular, there is lands coloured blue or purple there adjacent to the roadway. And it's in this area here that the IDA have a substantial land bank, and where they propose to build a new business park or develop a new business park in the years ahead. I suppose backing out a little bit, in the national context, the National Development Plan, the current National Development Plan, and the Regional Spatial and Economic Strategy produced by the Northwest Regional Authority identifies Sligo as a regional growth centre to drive growth in the region. It specifies the consolidation and the regeneration of the existing core of the city, and sort of requires the balanced urban expansion from the centre to allow for future growth requirements. And these documents, these national documents, have named the critically enabling projects. It's named for Sligo include the Western Distributor Road, the Eastern Garbo Bridge and Approach Roads, and the city centre public realm projects, which are also ongoing at the moment. I suppose this picture then will just give you just an overview, again, more detailed picture of the overall scheme. And I suppose the scheme itself, as Rowan said, has been developed in 2 phases. Up at the northern end, the first 600 metres was developed in advance. I suppose the reason for this was to allow the residential areas in the Kevensworth area to develop and be completed, and also to facilitate the development of the significant recreational area, which is the Mitchell Curley Park. Phase 2 then is, I suppose, from the Ballydugan Road right around to the Caltra interchange. And the proposed IDA Business Park is shown here and how it relates to the new road. And the new road will also allow or provide improved access to the existing IDA Business Park of Finniskillen. Another, I suppose, advantage or objective of the road is to, I suppose, the Sligo Inner Relief Road is a dual carriageway in as far as the Summerhill roundabout. And I suppose what the new road is doing is linking the residential areas to the east of the city centre, the southeast of the city centre. It will link them to the residential areas in the west, and I suppose provide basically these people now will feel like neighbours, as opposed to in the past they had to go into town and back out to those areas. So this provides a very quick link and improves connectivity within the city. It greatly improves connectivity within the city or the south side of the city. Okay, you can see the public realm enhancements which are going on in the city centre at the moment, the Eastern Garbo Bridge, and indeed the N4 traffic improvement scheme, which is improving the capacity of this junction here, the N4, N15, N16 junction. So just a quick word about the IDA and their role in this. I suppose the IDA strategy is to direct a significant proportion of foreign direct investment that it attracts to Ireland to regional growth locations where possible. Now, this isn't always straightforward, and a collaborative effort is involved from, I suppose, local agencies like the local county councils and agencies that deal with cities like Sligo. Like the attraction for the big attraction for foreign direct investment, they tend to gravitate towards big cities like Dublin. So we have to attract them to areas like Sligo. So the idea and ways that county councils like ourselves, like Sligo, and agencies within Sligo do this is to make Sligo indeed a more attractive place to live and do business. And also the county councils have a significant role in improving infrastructure and providing an environment where I suppose business can develop. I suppose the idea has got this substantial Oakfield Park or business park at Oakfield, and they have an objective to build a new business and technology park there. It's the next front, I suppose, in their developments within Sligo. So I suppose there has been ongoing partnerships with Sligo Council and the Department of Transport to deliver the Western Distributor Road over the last 5 or 10 years, and I suppose I suppose the provision of this roadway is part of Sligo's efforts to attract foreign direct investment to Sligo. I suppose the IDA already have secured a grant of planning for an advanced business technology building within the new business park. So I suppose the IDA are showing intent with the road just open to have planning already for a new buildings within that park. I suppose the Western Distributor Road and indeed I suppose the N4 Colonial Castle Baldwin Road, which will be opened in this year at some stage, are critical schemes for the IDA to enable them to attract foreign direct investment to Sligo. I suppose just dropping down maybe to detailed or some design objectives of the road. As I said, it's a strategic urban non-national road. It was built as a a single carriageway urban road, which will allow development access onto it, subject to planning permission. The scheme is to have significant active travel element in it, with significant cycleways and footpaths and facilities for pedestrians. The design manual for urban roads and streets inform the design, and the scheme is to be future-proofed with the provision of facilities to enable services to be provided. That's electricity, water, the wastewater, telecommunications, and so on. And the scheme also included, just to mention, a bridge over the Sligo Dublin railway line, which will be dealt with later in the presentation. I suppose then, basically, just an overview. The picture here shows the phase one, what's now called the Roger Eames Road, which has allowed the Mitchell Curley Park to develop and the whole residential area here to mature. That was opened, as Rowan said, approximately 10 years ago, and was developed by Gerard Love, or was the contractor with Gerard Love Contracts. Phase two, then, which is basically the subject of this presentation, started construction in January 2019. The contractor was Side Construction Limited and has been opened last month to traffic. So hopefully that gives you just an overview to Sligo and how the scheme fits into the overall development of Sligo and the need for the scheme. So I'll hand over to Ursula now, maybe to get into more of the detailed design of the scheme. Thank you very much.
Okay, thank you, Tom, and many thanks to Engineers Ireland for accommodating this presentation tonight for us. For those of you that may not know me, my name is Ursula Higgins and I'm a Technical Director with Atkins, and I currently lead up the Dublin Roads team. And just to give you some background to this scheme and our involvement to date, Atkins have a long-standing relationship of over 25 years with Sligo County Council, going back to the early 1990s, as Tom mentioned earlier, where Atkins completed the Sligo Traffic and Transportation Study. And within that report, we identified the need for a number of the road schemes, and they were identified as being the N4 Sligo Inner Relief Route and the Western Distributor Road. And for both schemes, the N4 Sligo Inner Relief Route and the Western Distributor Road, Atkins have provided consultancy services for all stages, from the initial concept stage through to handover. The Sligo Inner Relief Route was completed in 2005, as Tom mentioned, and phase one of the Western Distributor Road was completed in 2012, and now, as you know, the phase two of the Western Distributor Road was completed and opened to the public most recently in early January 21. So tonight, myself and my colleague Shane Tobin will give you an overview of some of the aspects of the design process that may be of particular interest to some of you. I will present Atkins' involvement in particularly the preparation of the project appraisal process and give you some insight into the Erin Road Erin processes that we went through in order to secure approval for the bridge over the Sligo to Dublin railway line. So in terms of the project appraisal process, for the Western Distributor Road, we carried out a detailed appraisal in consultation with the Department of Transport and in accordance with the Common Appraisal Framework 2016 version. And as you might know, depending on the threshold that your scheme lies within, and in this case, we were within the 5 million to 20 million category, a multi-criteria analysis as a minimum is required to be carried out. So in accordance with the guidelines, we carried out the appraisal of the scheme under the 5 headings of these here shown on the right hand of the screen. And they are economy, safety, environment, accessibility and social inclusion, and physical activity and integration. For the economic appraisal then, we did go one step further and we carried out a transport user benefits appraisal, otherwise known as TUBA. And in order to assess the safety benefits, we used a cobalt analysis. For the TUBA analysis, our own in-house traffic modelers used an existing Saturn model for Sligo town and its environs, where we added in the links and nodes required for the WDR route. And we then modelled that link in terms of the AM, PM and interpeak time periods in accordance with the Common Appraisal Framework for a base year of 2015, an opening year of 2020 and a design year which is always 15 years above the opening year, and that was 2035 in this case. In order to include the IDA Business Park, which is going to be a key component of the need for the scheme, it was important that the future traffic generated from this area was also included into our model. So therefore, in determining the demand growth for the traffic to be inputted into the model, we not only looked at the natural growth of the population and industrial sectors for the model zones, but we also reviewed the master plan development that was I suppose made public for the IDA park to estimate the total number of trips that would be generated upon realization of the IDA development. So in summary then, for the economic appraisal, what we did was we carried out that appraisal for a 30-year appraisal period, an additional residual period on top of that. And in terms of the overall objectives set for the scheme from the outset, we were able to demonstrate then from our project appraisal process that the scheme did meet the objectives. And I've listed on the next slide some of the key results arising from that project appraisal process. And they were most notably in terms of transport efficiency and effectiveness. We identified that there would be journey time savings in the order of 2 to 5 minutes from certain locations from traveling from one node to another. And also in terms of environmental impacts, we were able to demonstrate that the vehicle operating costs were reduced and the greenhouse gas emissions were also reduced, giving us a saving in the region of 4 million. In terms of economic opportunities, then the IDA Business Park at Oakfield was obviously going to be a huge generation of employment prospects for the area. In terms of relating to accessibility and social inclusion, again, the western area of Sligo town, which as Tom said, had been almost disconnected from the rest of the region without this link. This WDR route was now going to provide further increased accessibility to areas such as Maharaboy and Oakfield itself, which adjoins the scheme directly. In terms of improvements and integration to facilitate the development of a large area of zoned and generally undeveloped lands to the southwest of Sligo City. So that again brings us back to the slide that Tom showed earlier, where there were certain areas around the route that had been zoned for further residential development and also industrial development. And again, one of the main key objectives for the scheme was to provide increased access to the IDA Business Park, not only for the new one at Oakfield, but also at Finesklen, the well-established long-term IDA Business Park, which was close to the Ballydugan exit. And also this scheme was now providing an access and a linkage to the N4 itself without having to journey through the town centre. And I suppose in summary then, in terms of the overall project appraisal results, we were able to demonstrate that we did achieve a positive benefit to cost ratio number for both the 30-year and the residual appraisal process. So, and I think one of the key values that this scheme, I suppose, has brought, and Tom alluded to it at the start, is the number of increased pedestrians and cyclists that we now have on this route. That seems to have been a major impact of the scheme since it opened in early January, and it's great to see that the physical activity objectives that we had set out for the scheme right at the very start are now being realised and kind of going beyond what our view, what our estimates would have been right at the very start. So moving on then to the Éireann Road Éireann approval processes, and one of the more unique aspects of this scheme was the inclusion of the overbridge over the live Sligo to Dublin railway line, and the approval process that we had to go through in order to secure approval for the bridge and an overall agreement between Sligo County Council and Éireann Road Éireann. So I suppose to begin with, if you are setting out on this process for any of your current schemes, the main document that you would need to refer to is the guidance document on third-party works, which identifies, in essence, what you can expect to have to carry out as part of this process, who you need to contact, how permission to carry out the works may be granted, what activities Éireann Road Éireann will need to charge you for, and also what additional information they might require in order to satisfy their requirements, such as method statements, design approvals, or movement monitoring of tracks and the like. So within this particular document, the guidance on the third party works, there's a flow chart in here. It's called an activity flow chart. And that outlines for each phase of the works the activities to be carried out by the third party. And it includes an identification of the submissions that you have to produce and the outcome to be expected from that phase of the works from Éireann Road Éireann. So in essence, this flow chart here, it's a very clear flow chart, and it tells you exactly what is required, not only of the third party itself, but also of Éireann Road Éireann themselves, and whom they have to contact internally in order to satisfy their own requirements. I suppose just there are a couple of other technical documents that you may need to refer to while you're going through this process, and some of the more notable ones would be the technical approval for civil engineering structures, and also third-party works and railway safety requirements. There are two documents that you should also review. In terms of then the design process, the key principle really that Éireann Road Éireann stress in all of their guidance documents is that the works and the systems of works, both permanent and temporary, are planned and designed and constructed to minimise the risks to the railway. And really that is the ultimate end goal for all party involved, both the third party, the contractor, and also Éireann Road Éireann themselves. For the WDR scheme itself, and in line with the activity flow chart here, there were a number of documents that we had to produce as part of the design process and approvals regime. And these would include an initial assessment stage, and ideally that consultation with Éireann Road Éireann does need to be carried out at the route identification and route selection stage, so that you have raised the type of structure or the type of crossing with Éireann Road Éireann early in the process. And then once the route is selected, we prepared a preliminary design report and a safety assessment report. And I suppose one of the issues that we had, well, I suppose it wouldn't really be called an issue, but upon submission of our safety assessment report, there was a condition associated with the outcome of that approval process, in that two level crossings that were very close by to the proposed crossing point of the bridge, Éireann Road Éireann placed a condition that both of those level crossings had to be closed. And then I suppose the normal process then is your detailed design stage, and you have to submit to Éireann Road Éireann all of the detailed design drawings, the specifications, your design calculations, and also your check certificates. They all have to be submitted to Éireann Road Éireann as well, as part of the overall submissions process. And I suppose once you have really gone through and submitted all of the documents, and Éireann Road Éireann have consulted with the Railway Safety Commission and they've reviewed the safety assessment report, ultimately what you're actually looking for is an agreement to be signed between both Éireann Road Éireann and in this case Sligo County Council. So we were successful in that. But I suppose the process doesn't really stop there. What we then need to do is transfer a lot of those requirements that are identified in the bridge agreement into our set of tender documents. So this was particularly important. So you can identify to the contractor what they have to allow for in their program and also in the pricing of their works. So to this end and into the specification, we would have included items such as Éireann Road Éireann staff. And in this case, the Éireann Road Éireann staff that we were dealing with during the construction stage and just in advance of the construction stage were the staff in the Athlone division. And they, in essence, are almost, they take over the running almost of the approvals process on behalf of Éireann Road Éireann during the construction stage. In terms of insurance requirements, there was a myriad of insurance requirements stipulated in the agreement, and these range from motor insurance of 2.5 million up to about 25 million per occurrence for damages and losses. And just in order to ensure that the wording of the specification in relation to insurances is correct in terms of responsibility and legality, these sections were reviewed by IPB on behalf of Sligo County Council. So we would recommend that if you are putting such items into your tender documents, that they are reviewed by companies such as IPB. Within the specification, we also identified specific Éireann Road Éireann staff charges, and these would be charges for their staff to attend site to provide assistance such as lookouts, signalmen, etc. during the construction stage. So there is a charge associated with that, and that does need to go into your specification. And I suppose one of the other real important items that you do need to include in the specification is the possessions. And for this scheme, we estimated in the tender documents that we would need in the order of 20 days possessions. And again, what we had to do was agree the timelines and the durations of those possessions up front with Éireann Road Éireann, so that we could identify them within the specification. So we would have identified within the document the hours and days of the week that possessions could be facilitated, the duration of each, and most importantly then the charges associated with possessions, which are quite hefty, and not only in relation to identification of a possession, but also in relation to possessions and the penalties associated with it if there's time overruns on that particular night. So they were very important in terms of possession information that needs to be put into the specification itself. And again, then just in terms of overall notice periods, we did make it clear in the documents, and particularly in relation to possessions, that there is a minimum 12-week notice period that we have to give to, or the contractor has to give to Éireann Road Éireann in order for possessions to be approved and for Éireann Road Éireann to make their staff available for those particular possession days and nights. And then one of the final things I suppose that we would have had to cover within the documents themselves was for the construction stage and the approval processes that the contractor has to go through. And these would have been particular requirements in relation to safety, health and welfare, the need for method statements when they have to be submitted to Éireann Road Éireann and how far in advance. PTS training is another particular requirement of Éireann Road Éireann. Before anybody is allowed onto the track, they need to go through a particular training course, and there are only certain times of the year when that PTS training is carried out. So again, a lot of that was information that we wrote into the tender documents to complete the overall Éireann Road Éireann approval process. And I would like to just say that I do believe that there are a number of Éireann Road Éireann colleagues on the call tonight, and we would just like to thank them for their ongoing cooperation throughout the entire process, not just the design process, but also through the entire construction period. They were very accommodating, and we just would like to thank them for their assistance throughout the scheme to date. So that gives you a brief overview really of the Éireann Road Éireann approval process. Brían Flynn is going to bring you through the actual construction of the bridge now later in the presentation, and he has some really great photographs to show you of the various stages involved. in the construction of the bridge. So now I am going to hand you over to my colleague, Shane Tobin, who will outline to you the various design aspects associated with the WDR project. Thank you.
Thanks, Ursula. So thanks for that. So my name is Shane Tobin. I'm a senior engineer working with Atkins, and I suppose I've been working on this WDR scheme since joining in early 2017, seeing it through the design and construction phases as design team lead and assistant project manager. So I'll just take you through a few slides on some of the design features and then hand over to Brían, who'll talk you through the construction stage. So for the design of the scheme, so as mentioned by Tom, it's an urban road designed to allow for future development. It's nearly all in a greenfield site, apart from the tie-ins. So what we're looking at here are some key connectivity areas, which are notable, I suppose, especially in terms of active travel, as mentioned. So to the north, we have Mitchell Curley Park, the school, the GA grounds, and these are linked off to Ballydugan Junction. And then that junction in itself takes you back towards the city centre to the east, following the main line down towards the Oakfield Road in the centre of the scheme, which itself was realigned with two new roundabouts, north and south, the southern one that connects into the IDA development. And then following east along the main line across the railway and connecting onto the N4 dual carriageway. So the scheme was initially designed to NRA standards, which were current at the time. And then I suppose after a slight pause in the project, the scheme was taken up again and some new standard had been published in the meantime, DMERS and the National Cycle Manual, most notably. So there was some redesign work required to align the scheme with the new standards. So these provided the basis for the design guidance, and then the TI publications was used for the detailed design of the drainage, pavement, barriers, etc. And then also for the specifications, requirements for measuring and pricing, and standard construction details would have been taken from the TI publications. On the main line, so the speed limit firstly is generally 60 kph. It drops to 50 on approach to the junctions and roundabouts. The traffic carriageway is SMA construction, and we've got two 3.25 metre wide lanes, and then the same width in the centre, which is hatched out, and that's to provide future proofing for future right turn lanes for future development. On each side, then the curbs are 125 mil high upstands with 1.5 metre wide grass verges, and this serves to provide some protection to pedestrians and cyclists, and also gives them a greater sense of comfort. And I suppose the narrow traffic lanes, relatively high curbs on each side, and the significant hatching in the centre all help to promote lower speeds on the route. Then on each side we have 2 metre wide cycleways and footways. And then just to note that the footways, concrete footways, were reinforced at at each of the private access points along the scheme. And I suppose with the provision of these, the scheme is designed and constructed to give high quality connectivity for vehicles, and also then importantly for active travel users, recreational users along the full length of the main line from the N4 junction up to Ballydugan. One feature of note, I suppose, is just this vertical separation between the cycleway and the concrete footway. So that's a 50 mil high curb. And in this case, we implemented a curb with a 45-degree splay, which is a bit more forgiving to any errant cycles than a square edge curb. And it also proved particularly beneficial in terms of being able to be continuous across access points, and it's something that SIAC slip form construction were able to, I suppose, use to their advantage in terms of their slip forming operations, which Brían will discuss in a little bit. Also importantly for these types of schemes is good colour contrast. So you have the quite pale white concrete footpath against the black SMA surface. So that's an important feature for visually impaired users. On the side roads then, so again, we have 3.25 metre wide lanes with right turn lanes where required. And on this route, we had shared paths for pedestrians and cyclists. So that linked I suppose, the relatively short link from the shared areas at each roundabout, north and south. And a wide provision was provided in this case. So it's 3.8 metres wide, and there would be a lower pedestrian and cycle movement on this stretch of the Oakville Road. On the roundabouts then, so I suppose just to note that the diameter was slightly reduced when it was redesigned in line with DMERS. Some other features then, there's landscaping provided in the centre of the roundabout, which makes them more conspicuous on approach to drivers. And then for non-motorised users, so for cycles and pedestrians, they're fully segregated on approach to the roundabouts. And then combine into shared areas then as they approach the roundabout. So in each of these cases, then that's fully signed and tactile paving provided for visually impaired users. At each arm of the roundabout, then there's a 4 metre wide raised crossing provided, linking each shared area. So I suppose these are very conspicuous for approaching drivers. Again, with Belisha beacons provided each side. I suppose the advantage of these is they not only slow drivers, but they provide a more comfortable crossing for any mobility impaired users, as there's no level change between the footpath and the crossing point itself. At the other junctions then and crossing points, so the uncontrolled and controlled crossings, we've been keen to provide 0 mil, so completely flush crossing points. The standards do allow between 0 and 6 mil upstands on curbs at crossing points, but a fully flush curb does improve accessibility for all users. I suppose just one thing to watch on these is just the drainage position on gullies, I suppose, is important, particularly in these cases. Then at Ballydugan junction, you can see on the right hand side, we've provided 4 metre wide toucan crossings at each of the 4 arms. And then the junction itself is fully signalised, so it's a MOVA controlled junction. So there are loops installed in the carriageway. So these are vehicle actuated, and they continually adjust the green time for each approach, whilst also determining any queue impacts on the overall operation. Finally then, for myself, just a note on the services. So I suppose it was typical diversion works for the scheme of this nature, where there was any interaction with the existing road network or it was altered, but the majority of service and utility works were for future proofing for both future developments and for the IDA business park to the south. So for instance, the likes of the high voltage electricity, ducting and water main services were upsized for future development and for the IDA park. So for example, a 450 mil diameter water main was provided from the N4 back towards the Marboy roundabout, and that was a strategic decision agreed between Sligo County Council and Irish Water to future-proof that service. Then generally along the scheme, there's been future-proofing of electricity and telecoms through the provision of multiple spare duct networks, additional road crossings and chambers, and where closely located chambers have been provided, there's been interlinking ducting provided between them, so that allows for a more adaptable future duct network. And then finally, just an interesting feature, I suppose, that was promoted by Sligo County Council was the additional ducting provided on the public lighting network, which will allow for future proofing in terms of the provision of 5G transmitters to be added to the public lighting columns. So that's it from me, and I'll just pass over to Brían to discuss the construction stage.
Thanks, Shane, and thanks to the previous presenters, and hello to everybody tuning in tonight. So I'm just going to show you a few slides, starting off with one looking at the Western Distributor Road Phase 2 in numbers. I'll talk a little bit about the Éireann Rud Éireann Sligo County Council Bridge Agreement. I'm going to bring you through a few photographs that just set out the different elements of the bridge construction. I wish to talk briefly about the vehicle restraint system, and I'm going to finish up showing you a few slides on the footpath construction. So engineers like numbers. So the Western Distributor Road Phase 2 in numbers, the main line between Caltra and Ballydugan is 1.9 kilometres in length. The realigned sections of the Oakfield Road and the Ballydugan Road combine to 1.1 kilometres in total. We had to excavate approximately 92,500 cubic metres of unacceptable material during the construction. And because of the considerable embankments that we had to build either side of the rail bridge, we had an import of class 1 and 2 general fill exceeding 150,000 cubic metres. 30,000 cubes of class 6F material, capping material. Shane talked about the utilities ducting. So even though our scheme is only, the main line is less than 2 kilometres in length, believe it or not, we have 65 kilometres of ducting beneath the scheme. 3 kilometres of water main, 110 public lighting columns, all LED lighting, and we have approximately 94 tonnes of reinforcement steel in the bridge structure. So moving on to talk a little bit about the bridge agreement. So Ursula will have touched on this already, but really the bridge agreement is about granting Sligo County Council and the contractor temporary possession of railway lands in order to enable us to construct the new rail bridge. Now, one of the important items in the bridge agreement itself was that Sligo County Council were obliged to nominate a third-party designated representative. So once the construction scheme got underway, what that meant was that the TDP, or the third-party designated representative, was responsible for all communications with Éireann Rud Éireann personnel. So it wasn't a case that the contractor was querying something one day and the council something the next day. All communications were channeled through that person. And for the purposes of the Western Distributor Road, that was myself. Ursula touched on the idea of rail possession. So a rail possession, basically the council and the contractor became fully responsible for the railway lands during each and every rail possession. So the contract provided for a total of 20 rail possessions throughout the duration of the works, but SIAC's extremely efficient work practices, we only required 11 possessions to allow us to carry out the elements of the bridge construction that would have impacted on the railway line. So, as noted earlier, we were obliged to give Éireann Rud Éireann 12 weeks notice of each possession. Each possession allowed us to work on the rail track for roughly 7 hours, between 10:30 each night and 5 o'clock in the morning. And at the beginning and end of each possession, we were required to go through a formal procedure known as a handover, handback certification procedure, whereby the track safety coordinator would meet with myself on site. We would both complete what's known as a handover cert. The works would be allowed to commence once the last train had gone through and we were notified that the track was clear. And we had to be in a position to hand back the track no later than 5 a.m. And at that point, we would go through the handback certification, where there would be a joint inspection of the track between the track safety coordinator and myself. Then we would sign off on the certification. And at that stage, responsibility transferred back to Éireann Rud Éireann. Just to say that we established an extremely good working relationship with Éireann Rud Éireann during the construction stage. They were very, very accommodating at all times, and we'd like to thank them for that. Just one thing to note also is that post-construction and prior to the opening of the road to vehicular traffic, we had a joint inspection on site with Éireann Rud Éireann personnel and personnel from the Commission for Rail Regulation. So a little bit about bridge construction. So the image on the left is very early on in the construction stage. Basically all you have there is a piling platform. So how did we get from that to the image on the right, which is the completed bridge structure? And the image on the right is a photo that was just taken from the train last week by Colin Heatherly. So thanks for the photo, Colin. So looking at bridge construction and the primary elements of that. So you've got a working drawing here. This is a side elevation of the bridge structure. And I've basically outlined the 8 primary elements of that. So first one is the board concrete piles. You can see on both sides of the bridge. Once we get above pile cap level, these are extended in concrete columns. At that stage, we construct our reinforced earth structure. So this is the face of the reinforced earth structure here, with galvanized straps coming back into the earth behind. When the reinforced earth structure is complete, that allows us then to construct our column crosshead on both sides of the bridge, onto which we can place our precast beams. That allows us then to proceed to pour our diaphragm stitch either side of the bridge, to place our precast parapets, and finally our in situ parapet stitch. So looking at it in section, so again, you've got your piles all below ground, concrete columns extending approximately 7 meters above ground, and your column crosshead shown in green here, upon which our precast beams are placed. The light blue is our concrete deck, and the purple here is our precast, our in situ parapet stitch. So what does all of that look like in reality? So looking at stage 1 here, this is where we commenced working on our in situ concrete board piles. We had 14 in total, 7 on either side of the bridge. The piles were constructed using 40 Newton concrete, using 1 meter diameter steel casings, and you can just see some of the casings here behind some of the operatives. The piles were typically 9 meters in length, of which 2.5 meters is a rock socket. So we basically cored 2.5 meters into the rock below. The piling platform that you see here, that platform had to be designed to accommodate the piling rig on the right hand side, and that piling rig has an operating weight of 65 tons. So we had to ensure that the piling platform was more than capable of accommodating that piling rig. For each of the bridge elements, and as mentioned by Ursula previously, we had to go through the process of preparing temporary works design certs. So that's typically where the contractor, the main contractor, SIAC, would have their design engineers prepare calculations around the temporary works. And those temporary works calculations then would be passed over to Éireann Rud Éireann. And in some instances, where the works were likely to impact, or where a failure could impact on the operation of the railway, not only were we required to carry out a temporary works design cert, but we would also be required to carry out a category 3 check of the temporary works design certs calculations. So it's basically an extra independent check on the calculations. So the image that you see here on the right hand side then, before we could proceed to construct any of our main working piles, we were obliged to construct a preliminary test pile. So again, this was a 1 meter diameter pile, 9.5 meters in length. And along with that, we had to construct 4 anchor piles. So basically there's a separate pile on each corner. And this rig was brought in for the purposes of checking or testing the preliminary test pile to ensure that it was fit for purpose. So the test required a load of 4,961 kilonewtons to be applied incrementally on that test pile. That's approximately 500 tons. In addition to the static load test, we would have also carried out dynamic testing and integrity testing on all of the piles. So just looking at a few images here, we're moving on to stage 2 now, where our 7 piles are constructed on either side of the bridge. You can see the 7 piles lined up here. And at this point, we're shuttering on top of those piles to allow us to construct our 7 meter high concrete columns. So the middle picture there is just a photograph of the formwork that was used to allow us to construct these columns. The subcontractor would have had 2 of these shutters or 2 of these formworks, and you can see the 7 columns extending 7 meters above ground level in the picture on the right hand side. The concrete used here is 50 Newton concrete. The columns are 900 mil in diameter, and again, during the prior to construction stage, SIAC would have had to complete temporary works design certs and category 3 checks on the construction of the columns. So moving on to stage 3. Stage 3 is the construction of the reinforced earth structure. So the image on the left hand side is probably the image that most of us would be familiar with when we drive underneath a bridge, or when we're on the train and we're traveling underneath the bridge. The image on the right hand side would be less familiar to most of us. So what is a reinforced earth structure? So it's a combination of earth, or in this case, a granular material, and reinforcing strips. These are the strips that you can see here, which are capable of bearing large tensile stresses. So the 3 components of a reinforced earth structure are the precast panels, which you see here, the galvanized steel reinforcing strips, which you see laid out on the ground here, and obviously the granular fill that's built up in layers on top of these galvanized strips. So just an aerial shot of the same thing, and the purpose of this shot is just to show you how far the galvanized strips extend back from the reinforced earth structure. So there's the structure along the front face of the railway bridge, and the straps extend about 6.5 to 7 meters back from the structure itself. So the purpose of this photograph and the next photograph, they're both very similar, but what you will notice in this image here, you can see water ponding on top of this material. It's known as a 6I, 6J material. So this material must comply with the TII 600 series specification for works. So the grading must comply with the requirements of table 6.1, and then it must also comply with table 6.3, which is the limits of the material properties of fill for use with metal components. So we've got galvanized metal straps here. So we need to be satisfied that the material that we use, that it does not contain corrosive properties that would ultimately corrode or damage the strips when they come in contact with it. However, one thing that became very apparent to us was both of the materials that you see here, both the 6I, 6J in this photograph and the 6I, 6J material in this photograph, that material in both instances complied fully with the requirements, and particularly the grading requirements of the TII 600 series. Yet the material in the picture here had a very high fines content. So quite a high percentage of the material passed the 2mm sieve and the 600 micron sieve. The material in this photograph, less of that material passed the 2mm and the 600mm sieve. So its drainage properties were improved, and it was much easier to compact that material and ensure that we got proper compaction. The precast concrete panels were cast in Shea Murta precasts in Mullingar. The image on the left is just an image of the molds that are used to cast these, and the image on the right is just a stockpile of the panels ready for dispatch to Sligo. So there's not a lot I can say on this slide here, other than you can see the completed reinforced structure across the other side of the railway, and work has now commenced on the concrete column crosshead just behind the reinforced structure. On this side of the bridge, again, you can see work is shortly about to commence on the column crosshead. So what is the column crosshead? It's basically a beam that sits right across the 7 columns. It's 1.4 meters wide by a meter deep and 19.5 meters in length. And it's on these column crossheads that the precast beams will ultimately rest. So moving on to our precast beams, the beams were all cast off-site in Banagher concrete. This photograph just gives you an indication of the scale or size of the beams. So our beams were 23.5 meters in length. And I should have said earlier on, one of the reasons that the span on the bridge is so wide is to allow for the provision of an additional track, an additional rail track, should that be necessary at any point in the future. So the beams could only be dropped in during a possession, and as we mentioned earlier on, the possessions were generally from 10:30 at night until 5 in the morning. So SIAC successfully installed all 24 beams over 2 nights in the 6th and 7th of December 2019. And all I can say is SIAC and their subcontractors, Javelin Formwork, they deserve great credit. The installation process was managed with absolute precision. There was a huge sigh of relief once we had the first beam dropped in, and we were satisfied that the next 23 were going to fit as snugly as the first one. The process was complicated somewhat by the fact that there's a 9-degree skew in the bridge. If there was no skew, it would obviously be a lot more straightforward. And in addition to that, there's a 116 millimeter fall across the deck from east to west. But as I say, credit to SIAC and their subcontractor. The installation process went very, very well. And that was the time that Christmas parties could be held. I remember some of my colleagues from the roads department ringing up to check on progress, but to also tell us that their Christmas party night was going very well. So moving on to stage 6. So now we've got all of the beams in place, and it's a case of preparing the bridge deck and to receive steel. So this is the day after the beams had been dropped into place. And a couple of days later, you can see the mat of steel here on the left-hand side, ready to receive concrete. it mightn't be too clear, but there's some permanent formwork in place between each of the beams, just underneath the steel mat here. So the image on the right hand side, apologies now, it's not a very, very clear image, but at this stage now you can see that the deck has been poured. It's a 200 millimeter deck. We've got sleeves left out either side for the 250 mil water mains, which go through the bridge deck itself. And you can maybe just make out here that on the right hand side, we have yet to install the precast parapets. And we left some steel exposed here to allow us to tie in the parapets and to pour our parapet stitch. So like the other precast elements, they were all constructed off-site. The precast parapets here were manufactured by Banagher Precast. These were poured in an upside-down timber shutter. And the quality of them and finishes is quite good. You can see where there's lifting eyes left out so that obviously they could be lifted onto the transportation and for lifting into place during the construction stage. So again, SIAC would have had to complete temporary works design certs, which we would have passed over to Iarnród Éireann in advance of the parapets being placed, and also category 3 checks, again, to an independent check to ensure that the method statement and the design calculations were all correct. And this is a shot of all of the parapets temporarily propped until such time as the in situ stitch has gone off here. And what you see now is the completed bridge deck. Again, we've got our water main sleeves left either side here. We've got our in situ parapet stitch, and that bridge is ready to receive waterproofing and a sand asphalt carpet. So I just want to talk very briefly about the vehicle restraint system. So understandably, Iarnród Éireann require a very high level of containment to ensure that no errant vehicles end up on the track below. So our vehicle restraint system, our road restraint system, it must comply with the requirements of the TII 400 series specification for works. Now, because our scheme was tendered in 2018, we were operating under the November 2015 version of the TII 400 series. There is a more up-to-date version of that document, I think, issued during the past year. But nonetheless, looking at some of the conditions here, and particularly the conditions around testing of ground conditions. So the contractor is required to ensure that the finished ground conditions are suitable for the correct performance of the road restraint system selected. They must demonstrate that the finished ground provides sufficient resistance to comply with the requirements identified in the road restraint systems manufacturer's compliant installation manual. So it's important there to note compliance with the manufacturer's installation manual. Just moving down, where the above test requires in situ testing, these tests shall be undertaken at 50-meter centres and with a minimum of 2 test locations per restraint system length. And moving further down, if the site test fails to demonstrate that the ground conditions are suitable, the contractor shall provide an alternative system and or improve the ground conditions such that they are suitable. So they're all very, very important factors when you're installing a road restraint system. And just another point to note is that a check shall be undertaken by an independent chartered engineer who shall certify that the site testing regime is appropriate for the road restraint system installation in the specific site conditions. So the system which was proposed for our scheme, it was a system manufactured in Spain, and we were, in order to comply with the 400 series here, there were 2 tests that had to be carried out on our system. So the first test is basically, if you can picture it, this is a vehicle restraint system post here. The post is 2 meters in length. It's 1.35 meters below ground and the remainder above ground. A force of 8 kilonewtons is applied to the post, 550 mil above ground level. And at that point, the movement or the displacement at ground level should not exceed 250 millimeters. Now, in almost every instance that we carried out that part of the test in what I'm going to refer to as existing ground conditions, we easily complied with that requirement, with that part of the test. Part 2 of the test, however, requires that the post is pushed until this distance L is 450 millimeters. Sorry about that. So force is applied until distance L measures 450 millimeters. And once we achieve 450 millimeters at this point, the displacement or the movement at ground level should not exceed 150 millimeters. And if your test complies with part 1 and part 2, then the ground is fit for purpose. If not, we need to look at either an alternative road restraint system or improving the ground conditions. So just looking at that, this is what the test looks like in practice. So we've got the post driver here, the post in the ground, and the operative here is applying a load of 8 kilonewtons on the post here. So what you can see here is on the photograph on the left, this is the first part of the test where there's a load of 8 kilonewtons applied and there's a small bit of movement at ground level here. However, the image in the middle is a post that has been pushed 450 millimeters at a height of 550 above ground level, and the post has twisted and turned and we have exceeded the allowable displacement at ground level. This image here gives you an idea of the ground conditions, and looking at that, one wouldn't regard this as poor ground. It's very, very well compacted class 1, class 2 general fill, but yet we were unable to achieve satisfactory results in those ground conditions. So SIAC excavated the class 1, class 2 general fill, and we carried out some trials along the bridge embankment here. So you can see an area that has been excavated to a depth of approximately 1 meter, backfilled using a clause 804 material and compacted in layers of approximately 150 millimeters. So again, this is part 1 of the test been carried out, and you can see again the photograph. We've got somebody standing in the way, but you can see that there was very, very little movement during the first part of the test. The second part of the test, 450 millimeters of force applied at 550 above ground level, and the outcome here was a displacement of less than 150 millimeters at ground level. So again, just a few more images of similar tests. As I say, that the 400 series required a minimum of 2 tests for every length of barrier. So here's some more tests carried out, and you can see that the displacement at ground level is quite small. So ultimately, what we had to do, or what SIAC had to do, was excavate for the full length of the vehicle restraint system on the departure side and the approach side to the railway bridge, replace that with compacted clause 804 material, and we have a compliant system. That's a H4B compliant system. So finally, just to talk a little bit about slip form. So the image on the left will be familiar to most of you. It's a standard enough slip form curb. SIAC approached us during the construction stage and asked us if they could trial slip form footpaths. So we allowed SIAC to carry out a trial in their own depot in Dublin. Some of the personnel from Atkins had a look at the footpaths as constructed, and we gave them the green light to trial the system in Sligo. So as Shane mentioned earlier on, we had 2 metre wide footpaths and 2 metre wide cycle lanes. So this is the ground being prepared to receive the footpaths. This is a mold that SIAC constructed to allow them to effectively mold 2 metre wide footpaths. We've got a curb here and the footpath extending back towards the verge. And this is it in practice. So you can see the concrete extruded from the back of the unit here. And this is our finished product. While it may have required a lot more preparatory work in terms of preparing the ground beforehand, SIAC were able to churn out approximately 100 meters, 100 linear meters of slip form footpath per day. And they would come back and cut in the expansion and contraction joints the following day. So it was quite novel, and have to say we're very happy with the outcome. Just to say that the slump on that concrete was 20 mil slump to ensure that the concrete curb would stand up. So for those of you from Sligo, this is a view that I'm sure you're becoming very familiar with. The amount of walkers, joggers, cyclists, we always expected it would be quite a popular route, but it has exceeded our expectations. So just finally to finish up, a few images from the air. So this is an image from Caltra Interchange, looking back west towards Knocknarea. An image again from the railway bridge, and what you can see here is the Maharaboy roundabout and the slip road heading off down towards the IDA, the proposed IDA Business Park. This image is from Ballydugan Junction, looking east, again back towards Maharaboy roundabout. And finally, this is an image, an aerial shot that's taken from the just over the IDA lands. So we've got the IDA roundabout, or the Oakfield roundabout as we call it, in the foreground, Maharaboy roundabout here. This is the section of the main line heading towards Ballydugan, and Sligo town in the background, and Ben Bulben. So that's it. That concludes my presentation. I just want to finish up with a few thank yous. So first and foremost, I want to thank SIAC Construction and their on-site team. I'd like to say we worked very, very well with them during the construction stage. And I particularly want to give a mention to their main subcontractor, John Curran Plantower, who we were the really, really good subcontractor. I've already mentioned Éireann Rud Éireann and the relationship we had with them during the construction stage. And just to say thank you to both Colin Hedderly and Dave Aspel for their assistance during the project. Thanks to Shane and Ursula and Atkins. A very special thank you to Eric Gilroy, who is probably, of all of us, is the one who's most familiar with the scheme, having project managed it all the way through the tender stage and out the other end of the construction stage. And finally, to say thank you to the three lads who worked with me for the 2 years on site: Pádraig Keaveney, Michael Conway and Martin Cassidy. I couldn't have asked for a better team. So that concludes my presentation, and I'm going to hand you back to Rowan. Thank you.
Brían, thank you very much. And I suppose Tom, Ursula, Shane and Brían, just to say thank you very much for a great presentation. It gives us all a great feel for what's involved in delivering what is, I suppose, a very strategic scheme for Sligo. I suppose although its true benefits won't be fully realised until traffic levels return to normal, given COVID, etc., I think everyone will agree that it's a game-changing project for the city of Sligo. So look, we might open it up for some questions, if that's okay. A reminder, if anybody wants to submit a question, to do so in the Q&A section and not in the chat box. I think we have a few in there already. I'll just go through a few of them. So we start off with Porrick has a question here. Probably Tom, probably this one is for you. Scheme was conceived in 1975 and then revisited in 85, 95, 99. Atkins finally engaged in 2002. That was a fair question. Why does it take 45 Earth years to get something necessary done in the Republic of Ireland?
Sorry, you can hear me there, can you?
Yep, can you hear there, Tom?
I suppose basically it's the nature, without getting into it in detail, it's the nature of public works or public contracts and or infrastructure in Ireland or in most countries. I suppose it's good that it was planned so many years ago, so that it was included in development plans, and so that that facilitated the development of it when we did go about developing it. But I suppose you must remember there was an overall transportation plan, and we first had to deliver the Sligo Inner Relief Road first. So that was number one, and that wasn't open until 2005. So we did actually start developing the Western Distributor Road ahead of even the Sligo Inner Relief Road being built. I suppose the Sligo Inner Relief Road itself took a long time to be developed. So, and since we started it then, we've gone through one or two recessions, and funding, from a funding point of view, you're competing with every other or there's very limited public funds for these projects, and you're competing with other areas around the country who are trying to build similar projects. And I suppose it's a non-national project as well. It's not a national road project. So I suppose the national roads during the national development plans will have got more funding as well. So we had to work hard to work with all our partners and stakeholders to get funding for the project in the end. So yeah, it does take a while to deliver them, but that's probably the nature of these projects.
Yeah. Okay. Thanks, Tom. Question there from Paul McNulty. How did the 45 degrees splay sit with the National Cycling Manual detail? Maybe a question for Shane or Ursula.
Yeah, so I suppose there's a similar detail in the cycle manual where there's frequent entrances. There's a bevel curb detail called up, and it has been used elsewhere. This detail, I know around Maynooth near the train station, it's been used on some similar kind of raised adjacent cycle lanes as a detail between the footpath and the cycle path. I suppose it does add a bit of, it makes the curb more conspicuous, especially for these lower height curbs, the likes of the 50mm curb. And if someone does, cyclists do, I suppose, inadvertently or intentionally try to mount the curb, there is a bit more forgiveness in it. But yeah, so it's similar to the bevel curb that's called up in the cycle manual at entrances.
Yeah. Okay. Thanks, Shane. Porrick, another question here, just in relation to tactile paving, saying that there are 5 tiles wide. His employer uses 6. Any comment on that, Shane? Or?
Yeah, it just depends on the width. So the DMARS does allow for 2 meter wide crossings between 2 and 3 meter wide. So it depends on your location and the demand. So a 2 meter wide crossing would end up with 5 tiles. So we generally had, I suppose, at the main crossing points have been, the roundabout and at Ballydugan Junction, it's 4 meter wide toucans and zebras, and then kind of at the minor crossing points, it might drop down to 2 meters, and that's where you get your five tactiles.
Yeah. Okay. Thanks. And another one from Porrick then. So how does one know Iarnród Air and Irish Rail's requirements? Are they advertised on the internet, or do you just get them once you invite it?
Maybe I could just say that, just I suppose with Irish Rail in general, I suppose we did engage with them very early in the whole process, way I'd say, before any work started, before any design work started. I think it was Michael West at the time from Irish Rail, and that's where we were first introduced to the guidance documents, the third-party guidance documents. So Irish Rail did provide them to us right from the start. So there were a roadmap as to how to work with Irish Rail And by following those guidelines, I think it led to great success. We didn't try and skimp on anything, and we got the approvals all along the way, you know. But those guidelines are on their website. Google them and you get them.
Okay. Great, Tom. Thank you. Just another detailed question there from Paul. Are there any safety considerations for cyclists and pedestrians using the crossings of the approach legs to the roundabouts, where there are 2 lanes of traffic approaching the roundabout?
I can take that one. Yeah, so I suppose for our scheme, there was quite limited 2-lane approaches that were very localized to the crossing point itself, just on approach to the roundabout. But I suppose generally for other schemes, its visibility is the main issue. There's a detail in the TII publications in the 5000 series standard construction details that kind of covers it in terms of making sure you have correct visibility left and right if you do have a 2-lane approach. So it might be different, I suppose, if you have a long stretch of a 2-lane approach to our case, but that's probably the point of reference, that TII 5000 series SCD. Yeah.
Okay. That's great, Shane. Thank you. Val has a question, maybe for Brían, possibly, just inquiring about what bearings were used for the bridge beams.
Okay, so there's no bearings in the bridge beams. They're placed directly onto the column crossheads. And the bridge is an integral bridge, so no requirement for bearings.
Very good. Another question for you, Brían, from Jim. Was the vehicle restraint system for the entire scheme or just at the bridge section?
So it's primarily at the bridge section, at the approach and departure side of the bridge, but then also at the Caltra interchange. So the same testing requirements apply to both.
Okay, great. Just some compliments there from Francis Fidgen and Colin Heatherly on tonight's presentation. Next question there from Sean McGrath. What volume of traffic are you expecting in the design year, peak or AADT?
I can answer.
Yeah,
I can answer that one. I suppose just looking at the project appraisal. So for the design year of 2035, for the AM peak, we had passenger car units in the order of 9,000.
Okay, thanks, Ursula. Colin Heatherly is asking, were there any special environmental issues or considerations in the scheme?
So I'll just come in on that one. We have badgers, a badger set very close to the railway track, actually, just on the west side of the track. So we had to provide a badger underpass, approximately 100, maybe 150 meters west of the bridge. And in addition to that, we had some bat surveys where there was a requirement to remove some trees on the Oakfield Road. But that's really it.
Okay, and Brían, can I ask, do the Badgers play for St. John's or St. Mary's?
They're the St. Mary's side of the bridge, Rowan.
Right, okay, thanks for that. Question there from Sean Martin, just asking us to talk about road drainage, attenuation, existing stream diversions. Were there any issues to agree with Irish Rail in relation to outfalls into the existing open culverts either side of the railway line?
Okay, so in terms of drainage, everything from the rail bridge towards Ballydugan drains to an attenuation pond across the road from the Gaelscoil or from St. Mary's GA. We've got a petrol interceptor on the outfall from that attenuation pond, and also a control valve that limits the control during high rainfall. And likewise, we have an attenuation pond over in Caltra, so everything from the rail bridge back to Caltra discharges to that attenuation pond, and likewise petrol interceptor and control valve on the outlet there.
Okay, thanks. I think it's something you touched earlier on. Rowan has a question there about movement joints constructed. Were the movement joints constructed afterwards in the slip form, footpaths and curbing? I think you mentioned earlier on that they were saw cut the day after they were laid. Brían.
They were saw cut the day after, yes. Yeah, no
okay.
problems.
Okay, very good. Matthew's asking, is there a time scale on the IDA park development?
Maybe I'll just, I suppose basically the IDA have, I suppose they've already got planning permission for a building there. I'm not quite sure when they intend to start building that, but I suppose the IDA park now, the IDA can market it. They can bring investors to Sligo. They can show them the road, they can show them the business park. And I suppose it depends on how quickly they will attract a new business to the area as to how quick. But I'd say the park itself will be a long-term, an area where the IDA can be attracting foreign direct investment to Sligo for the next generation. It's not for the next year or two. Look at the existing Finniskillen Business Park that was started in the 70s, and it has been developing since then, and it's only now that it's approaching that it's full. So it's providing thousands of jobs, and Oakfield will probably be the same as the years go by.
Yeah, man, look, it's great that the services have all been future-proofed, and it's great that there is advanced planning there for an advanced building already. So that's great. Okay, thanks, Tom. Shane is just asking, was any lime stabilization required?
It wasn't provided for in the original contract. However, SIAC did at one point explore it, but the quantities that we could have used for the purpose of lime stabilization would have been so small that it wouldn't really have merited it.
Okay, a question here from Sean, probably hard to answer given COVID effect on traffic, but what has the uptake and the usage on the route been like? Any particular trends between industrial HGVs, pedestrians, cyclists? Has there been much of a noticeable relief within the town? Probably hard to gauge it at this point.
Well, I suppose if we could comment on that, we did put out 15 traffic counters at key locations back last September, October, and thankfully before the schools had closed. So we do have quite a lot of before data. So counters were placed on the Inner Relief Road, the likes of Ballyskey, Finniskillen Road, Church Hill, the existing Oakfield Road, and the Roger Eames Road. So it's our intention to place those counters back out the same locations, plus a few additional ones on the new road when schools do reopen, so that we can compare like for like. That's possibly April, May this year, who knows. And then in addition to that, like we can say that in terms of footfall, numbers are fantastic, and so much so that we have also placed 4 footfall counters out on the scheme. We haven't had a chance to download them, but we are gathering data.
Very good. Thanks, Brían. Just a few votes of thanks and praise there from Michael, Vincent and Damien. Just excellent presentation. Stuart is asking a question there in relation to the cross-section, the width of the road. How was it determined, and what is the reasoning for the continuous white central hatched median? I think it was touched on possibly in Ursula's or Shane's.
Yeah, so I suppose the central median is for future proofing for any development that happens each side, in terms of allowing right turn lanes, and then the lane widths themselves, I suppose, are standard. They're determined based on the speed of the road, so they're narrowed down to a 3.25 meter wide lane, which would have been narrower than the original proposal when it was an NRA design scheme, and I suppose the narrower lane is to encourage lower speeds and better speed compliance.
Yep, great, thanks Shane. Tony is just asking there, was there any reinforcement in the slip-formed footpaths, Brían?
So there's reinforcement at the field entrances, at the agricultural entrances, but not beyond that, no.
Okay, grand. Barry is asking, was there any issues getting the banner parapet beams placed due to reinforcing clashes between the parapet beams, excuse me, and the deck reinforcing projecting into the stitch slab?
Nothing more than one would expect in a bridge as you know, the level of complexity that ours had. No, it went pretty well, and as I said earlier on, we had a huge sigh of relief when the first beam was placed, and we knew that the beam length was correct and the reinforcement was in the correct location and so on. So no major issues.
Okay, that's great. I think Joe's, I suppose he's saying what we're all thinking, and just to say well done all and excellent presentation. And look at, I think Michael is squeezing in a quick question there at the end. Where was the unsuitable material disposed, I suppose Michael is asking.
Okay, so adjacent to the LMA, the lands made available, we had three pieces of land in the ownership of Sligo County Council acquired for the purpose of the scheme, and which would have been quite low lying after construction of the embankment. So therefore we used the unacceptable to raise the level of those lands.
Very good, thanks. John Green has come in there. Great addition for cyclists linking cycle lane to the cycling facilities on the Strand Hill Road rather than have to use either Oakfield Road, which is, yeah, good point. Tim Ahern, well done to all concerned. Construction needs this level of proactive partnership between employer, designer, contractor. I think that's a very fair point. I think the success of that collaboration is very obvious. Thomas Foy is asking, was there much working, troweling, brushing required to achieve required finish on the slip-form footpaths? And would imagine that a slump of 20, there's not much time to work the concrete.
No, so within the mold that was that SIAC manufactured for the footpaths, they had 5 vibration pokers. So like when the concrete came out of the mold, it was as you saw it there in the photograph. You know, quality was very, very good. Obviously, there was brushing to be done, and where they were crossing manhole covers, there was quite a bit of work around the covers. But other than that, no, it's a really good system. Hats off to SIAC. It's really good and worked really well on our project.
So we're likely to see a bit more of it. Yeah.
I suspect so, yeah.
Yeah, great. Sean just saying, informative, interesting presentation, excellent project, well done. Tony McManus is asking, were the signs subjected to the same ground resistance movement checks as barriers? Brían?
Were signs
subject I think it's just the testing of the posts for the barriers, obviously different. Don't need the same.
Not that I'm aware of, no.
Yeah. Gordon is saying congratulations to all involved, and Shane is asking, was there any reduction in pavement thicknesses from design to construction phase given TI's circular economy plan?
No, we stuck with the design pavement thicknesses throughout.
Yeah, okay, that's great. Right, Brían, listen, thank you very much for taking those, and to our panel. And look, just to say thanks to everyone for your questions, and we'll conclude the Q&A now. So look, just to say on behalf of the Northwest region, a big well done, first of all, to everyone involved, and also a big thank you to